The aim over here is to show you how raw traces or packet captures are converted into data records by passive probes. As an example, be that a phone in mobile environment or a CPE in a fixed environment generates traffic. Multiple users can be behind a CPE, all the way from an application layer 7 to a physical layer 1. Okay, generally we attribute them or call them as PDUs. However, fundamentally speaking, an HTTP packet gets encapsulated in a TCP segment, which then encapsulates into an IP packet, then into an Ethernet frame, gets converted into bits, and then gets transferred over the physical layer. As a practical example, here is a physical capture from a Nokia eNote B back in October 2014. The only thing that you need to be careful about in Wireshark, the sequence is a bit flipped. The physical layer appears at the top, followed by the Ethernet, so on and so forth. So you can see that graphically notated over here. So just be careful about that. So you've got layer 1, layer 2, IP, layer 3. It is important, however, to note that this follows the exact reference stack. So this is the reference stack courtesy NetHawk or X4. Okay, you've got the layer 2, layer 1. So this is layer 1, layer 2. Then you've got the outer IP, which is the network IP. Okay. Then you've got UDP, then GTP user plane, GTP-U. Why? Because we know that GTP uses UDP as a transport protocol. Then we've got the again an IP, which is the inner IP. So this is the inner user IP. This is the outer network IP. Then we've got TCP in this case, because basically this is the initial group of pictures of a YouTube layout. You can see multiple TCP segments have been used to reformat this get object. Okay, and eventually is the media itself, which in this case is video. So I've just put a small screenshot over here from VLC in which you can actually see some basic media attributes as well. Now let's go to the next part where I explain how this is converted into data records, or XDR, or application specific data records. Now let's see how actual data is actually translated into data records. Okay, I just told you how protocol data units work. We expect to see in the internet traffic in both sides, going from the user towards the internet servers, as well as from the servers down towards the users. Okay, and each of these packets will contain different protocols, protocol data units, HTTP, TCP, IP, etc., like I explained in the previous section. Okay, and now let's see how a passive probe installed somewhere in between in the chain doing deep packet inspection translates each and every protocol data unit, HTTP, TCP, IP, in each packet into records. So one row for each protocol data unit. So let's say if I take just this one packet broken up with HTTP, TCP, IP, protocol data units, how does that translate? You can expect for HTTP, let's say between these two, one is a post, the other is a get. You will see the client IP address, you expect to see the user agent, and fundamentally speaking, the aim of the deep packet inspection probe is to take the key attributes or metadata like the request type, the client IP address, the user agent, etc., and put it as a database record, which can tomorrow be then aggregated, queried, processed, etc. Okay. Similarly, for TCP, we expect to see source ports, destination application ports, sequence number, acknowledgement numbers, etc. And I'll also come to the fact that other than the pure inspected, visualized information elements or attributes, there are some other calculated attributes as well, the likes of throughput, volumes, latencies, etc. Okay. When we come to IP, let's say for this one packet, this TCP yellow one signifies the inner or the user IP address, that record, whereas the UDP one signifies the network or the outer, which is using UDP as a protocol, transport protocol. Okay, so you expect to see the source IP address, the destination IP address, the DSCP point code, the DTL, etc. Okay, it is very important to note that there are three types of metadata attributes for each protocol data unit. The simple ones, the reported ones. Straight away you inspect, you populate into the database. Next are parameters also negotiated on the fly between the client and the server, the likes of window scaling, maximum segment size, codec settings, etc. The tricky ones and the ones that you must always be careful about are the calculated ones, the likes of latency, volumes, throughputs, byte in flights, etc. Okay, because we can have inaccuracy, especially in the case of aggregation. Now let's move to the next part in which I show you how the user, once he actually browses, views a streaming video, how does that translate into data records? How does that simply look like? and what types of capability do deep packet inspection systems actually possess. So here is an example of a person browsing a website where each HTTP object, and I've numbered them. Okay, you can see it's a full variety, which content coming from different data, or different websites or servers as well, is translated down into each data record. Okay, in this case, let's say it's all downlinks, so these are GET requests. Okay, and you will see the URL, you will see the content type as well, you will see the user agent, you will see the let's say client or server IP addresses and ports as well, and lots of other details. This is as an example from one specific DPI vendor's user plane probes. But remember, the key part is as people browse and digest internet traffic, be that in the form of browsing or streaming, billions of such data records are generated with rich information elements or metadata or attributes, as we call them, which are these columns. Okay, so you can imagine billions of records in, and each one containing multiple records or information, let's say columns or information elements, which can vary per protocol or application that you are actually using. So let's see, I'm giving you an old reference. This is from 2011, courtesy Cosmos. So, and again, a very short excerpt. At that point in time, they could inspect around 1,000 protocols. They've categorized them under different types, but you can just get a flavor that, let's say, for a typical networking protocol like DNS, they can generate 14 unique metadata or information elements or attributes, which means the columns. Okay. Similarly, for L2TP, which is relevant with respect to fixed, TCP, universally very important for email or webmail based protocols, for instant messaging or conferencing apps, for different types of forums, browsing, very relevant and important. You can clearly see how the number of attributes or elements decreases when we go in an encrypted mode between HTTP and HTTPS. Similarly, be that for social networking sites, streaming, video, OTT, which is mostly nowadays MPEG-. And again, remember, since 2011, a lot of this would have seen a delta increment. Okay, so lots of examples I've given relevant to our focus right now. So for search engines, for VoIP, which we use quite extensively in the fixed as well as the mobile domain, peer-to-peer, gaming, enterprise, and many other different categories are also available over there. So it's important really to see the strength of a deep packet inspection in terms of attributes, reported, negotiated parameters, or calculated, very importantly. So when we come to the performance of different applications, the calculated metrics become very important. Okay. Thank you.